Hi guys. In this lesson I'd like to show you how to do a few of these problems that asks you to multiply rational expressions. Okay, so we're going to do the basic problems first, and the basically the idea of doing these problems is to factor, cancel, and to multiply across. So let me write those steps down. So you have to, here are the steps, okay, and the steps involve is factor, okay, cancel, and multiply across, okay, multiply across. So let's follow these steps on this first problem, okay? Now, it says multiply the following rational expressions and simplify the result. In this case, you can see that we have monomials on the top for both values of the numerator and the denominator. So in this case, when everything is a monomial, there's really nothing to factor. So we're going to go right to the canceling part. So I'm going to write -1 over 2b times 6 over 7b squared. Okay, now I'm going to use a different color. Let me use the purple. And what we're going to do now is we're going to cancel like factors in the top and the bottom. Now you could actually cross cancel here too because it's a multiplication. So if you want to think about it, you could actually think about this problem as being just one problem that has multiplications on the top and the bottom. All right. So in that case, we know that 2 here, the 2 here goes into 6 3 times, correct? And really, I think there's really nothing else that we can do here, right? There's really no other common factors in the numerator and in the denominator for us to cancel. So now it's time to just multiply across. -1 times 3 is -3. And b times 7b squared is 7b cubed. Okay, so we're going to type that in now. Let's type that in. We have -3 over 7b cubed. Okay, we also have to, they want us also to identify the values for b for the result to be equivalent to the original expression. Can it be defined at b equals 0? Well, at b equals 0, the denominator is going to go to 0, correct? So b cubed is 0 times 7, that is 0. So therefore, we're going to say no. Okay, this expression cannot be defined for b equals 0. And let's check, and that is correct. Okay? Okay, now let's go to the next problem. Now we have a division. So what we must remember in a division is we want to turn this into a multiplication. So before we actually start doing the steps, we want to use keep, change, flip. All right? So always turn a division into a multiplication. Always make a division into a multiplication using keep, change, flip. So using keep, change, flip, okay, we're going to get the following. Let me use blue here. So 2x to the 4th over 7 times, right, keep the first, change the division to multiplication, and flip the second. So we have 4 over 5x to the 4th. And again, we use that process of factoring, canceling, and multiplying across. Again, these are all monomials, so there's nothing really to factor. So we're going to think of it as one big division symbol, right? and with the multiplications on the top and the bottom. Now let's see what we can cancel. Well, looks like the x to the fourth on the top is going to cancel with x to the fourth on the bottom, right? And I think that's about it. So let's write our final answer. We have 2 times 4 is 8. And then we have 7 times 5 is 35, correct? So this just works out to 8 over 35. All right, so we're going to write the answer down here. 8 divided by 35. Okay, and then it says, again, can this be defined for x equals 0? Well, unfortunately, once we did keep change flip, okay, before we did the keep change flip, we only had constants, a 7 and a 4 in the denominator, so it was defined. However, once we did the keep change flip, then we got the 5x to the fourth now in the denominator, and therefore in this case the x cannot be 0, so we're going to say no. Okay folks, so yes, this has to be defined. X equals 0. That has to always work. That has to also work not only for the original but also for the expression once you apply keep change flip. Okay. Next one. Multiply the following again. So in this case, we can, again, we don't have to do keep change flip because it is multiplication. So let's take a look. Let's do it. We have 4 over 5y cubed times 1 over 12y to the 6th is equal to. All right. Again, these are all binomials. There's really nothing to do. There's no factoring to do. So we're going to treat it as one big fractional expression. Okay, one big rational expression. And now we can cancel. So the 4 goes into 12 3 times. And again, I think that's about it, right? There's really no other common factors in the numerator and the denominator. So our answer is 1 over 5 times 3 is 15. And y cubed times y to the 6th is y to the 9th. So let's write that as our answer. 1 divided by 15y to the 9th. Okay, that's our answer. And again, is this defined for y equals 0? Again, y, we have y in the denominator. Therefore, if we plug in 0 for y, that'll make the denominator go to 0, making the whole expression undefined. So again, we're going to say no. Okay, folks. And then finally, last problem. This is again a division. So we're going to use keep change flip. And let's change it into a multiplication. Negative 9 over 2b squared times negative 7b to the 5th over 15. Okay, here we go. Again, they're all monomials. There's nothing to factor. We're going to treat it as one big rational expression since it's already a multiplication now. Okay, so it's multiplied on top, multiplied on bottom. And let's see if we can cancel out some common factors. Definitely we see here a b squared, right? That's going to cancel out with b to the 5th, leaving us with b cubed, right? B squareds are going to cancel out. And then we have a 9 here and a 15 here. Actually, we have 3 here, right? And that's for the exponent, sorry. So we have a 9 here and a 15. So common factor of 9 and 15 is 3. So it looks like that's going to be 3. And 3 goes into 15 5 times, like that. And I think that's it. So now let's write out, multiply across. We have negative 3 times negative 7 is positive 21 b to the 3rd over, and then we have 2 times 5 is 10. All right, and I think that's our simplified expression. So we're going to write that 21b to the third, okay, divided by 10. And again, the question they're asking is, for the result to be equivalent to the original, can it be defined that b equals 0? And again, if we define b at 0, it'll turn the denominator 0. Therefore, again, our answer is going to be no. And that is it. Okay, guys? All right. Take care.